Today's video is on solving systems of equations using the elimination method. The steps to solve by elimination: you're going to line up the equations with the x's, the y's, and the constants. Then you're going to multiply both the equations possibly to get a variable having the same coefficient. You can add or subtract after to eliminate a variable, solve for the remaining variable, and then substitute your answer back in. Let's do number one. Number one, they are already lined up in standard form, and we have a variable, in this case the x's, that have the same coefficients. The next step is to take your two equations, I'm going to rewrite them here, and are you going to add them or subtract them in order to cancel out the x's? Here we're going to subtract them, because if we added them then it would make 2x, so that didn't make sense. Subtract them, they cross out. The y's now become 8y's. Be careful. 7 minus negative y is a positive 8y. And then a 17 minus negative 7 is a positive 24. Dividing both sides by 8, we get y to be 3. So we lined them up. We multiply. Well, we didn't have to multiply. Here we subtracted, and we solved. The last step is to substitute. So we're going to take the y equals 3 and substitute back into any equation. I'm going to do the bottom one because that looks like definitely an easier equation to solve for x. So we have x minus 3, and for y equals negative 7. So x is going to be negative 4. And the way you write your final answer is, of course, an ordered pair of where those two lines intersect, and they intersect at the point negative 4, 3. Let's do another one. Number 2. I'm going to rewrite the problem over here. So we got 3x plus 2y equals 22. They are both in standard form, so I don't have to rearrange them at all. Now, do we have to multiply or change any of the coefficients? We do not, since we can already cancel out these y's here, and we can cancel them out through addition this time. Adding 2 and negative 2 cross out. So we have 8x equaling 64. Dividing both sides by 8, we get x to be 8. Next, substituting in 8 into one of the equations. I'm going to do the top one because I guess there's smaller numbers. It's a little easier. So we got 3 times 8 plus 2y equals 22. Continuing to solve for y, we get 2y to be negative 2, and then y to be negative 1. We write our final answer as an ordered pair, 8, negative 1. Let's go on to another one that's a little more challenging or that has a special case. Number 5. They're already in standard form. That's great. So check that off the list. Next, they both don't have a coefficient. So the x's aren't the same, the y's aren't the same. Pick one of them to make the same. I'm going to make my x's the same. In order to make my x's the same, I'm going to do some multiplication. I'm going to multiply this whole top equation by 2 and the whole bottom equation by 5. Doing that makes my top equation 10x plus 6y equals negative 14. Don't forget about that C value multiplication. And then multiplying the bottom, we get 10x plus 35y equals 15. So now we have x's in this case that have the same coefficient. Again, it doesn't matter if you do x or y, whatever's easier for you. Now we do our subtraction or addition. Here we have to do subtraction in order to cancel out the x's, and we're left with negative 29y equaling a negative 29, because negative 14 minus 15 is negative 29. Dividing both sides by negative 29 to make y to make a positive 1. Now we just substitute that back in, and you can substitute that into these equations or any of these two. I'm going to pick the one with the smaller numbers. I'm going to do that one. So we get 2x plus 7 times parenthesis 1 equals 3. 2x plus 7 equals 3. Subtract over the 7. X is going to be a -2. And again, you write your final answer as an ordered pair, x, comma, y. All good. Write down what questions you have on that type of multiplication for elimination. Number 6, I think, is a special case, so let's take a look at that. It's in standard form, but I need to make one of the variables be the same. I'm going to do that for the x's again, and they look like a little smaller numbers. I'm going to multiply this by 4 and this by 2. So I get 12x minus 36y equals 36. And on the bottom, I get 8x, or not by 2. Why did I do that? By 3. Hopefully you caught my mistake. 12x minus 36y equals 36 times 3. Let me just type that in. 108. I can kind of sense something weird happening here since we have a lot of the same numbers. But let's just continue to solve. So we got to take away the x's. We subtract those. X's go away. But not only do the x's go away, but the y's also cancel here, because negative 36 minus a negative 36 makes nothing. So we have 0 here, and then we have 36 minus 108 on the right side, which is a negative 72. Think about your special solutions. Are the lines parallel? Are they the same line? Are there infinite solutions or are there no solutions? Here, my final answer, 0 equals negative 72. That's a false statement. If it's false, that means there's no solution, which further means that these two lines are parallel. They do not cross. There's no intersection point, so there's no solution here. Write down what questions you have on solving systems using elimination. We'll get to word problems next time. Have a great night.